Okay, so we've defined our class, our template, but on the whole, we're not working, in our programs with the templates, we're working with instances of that class, of that template. So I guess the next step is to find out how do we move from that template to creating instances of our classes, creating objects.
Yes. So obviously, like you just said, we're working with objects, instances of objects, rather than the actual classes. You're going to take the class, you're going to create an object from that class, and then you're going to use that object to do all of your manipulation and your actual coding. So to do that, let's take a look at an example. Here we're going back to our old main again. If we wanted to create, for example, an instance of our foo class that we were looking at in the last section. Just like any other variable, we have to start off with the type, the variable type. And as we talked about when we were talking about pointers, objects are always declared as pointers. So you have basically a pointer to a foo object, right? So foo asterisk. And then we name that. I'm going to call it, let's say object here, obj.
I guess that's because now we're dealing with complex data types effectively with code and everything. I guess it's our data is going to be up in the heap.
Yes, that's correct.
But we need some way of accessing data in the heap, so our object itself is just a reference to the object,
to that data
because the reference is on the stack.
Yep, exactly. So, and again, we have to name our variable that we're actually going to store this data in. So we're going to do like object and then equals, just like any other variable. Now this is where it gets kind of interesting. It used to be, we could just like stick some kind of value in there, and we're basically going to kind of do that as well. But the way we're actually going to get the data that we're going to store in there is by calling some special methods.
Okay.
The first thing that we're going to call is actually on the foo class itself. It's a class method on foo. It's to create one of these, it's a kind of a two-stage process. So first we do foo alloc. So we're actually calling the alloc method on the foo class. That's a class method.
Right, okay, so it's exactly the same as we declared our type for our variable is foo. We're now using the same keyword, effectively the class.
The class name.
And calling a method on it.
Yes, we're calling what's called a class method. And that's a method that's part of the class itself. It's defined on the class. Remember, I talked about that plus symbol that we'll visit when we start talking in more detail about class methods.
Right, so we haven't covered it yet. That's great.
Right.
I wasn't missing anything. We hadn't covered it. Now, we haven't written an alloc method.
Oh, no, we have not written an alloc method. Alloc is one of those methods that's actually provided for us by NSObject itself.
Inheritance.
So, through inheritance, exactly. And really, the purpose of the alloc method is just to allocate the memory on the heap that will be used to store the data that is our object.
So
that's what alloc does.
Creating this blob of memory up here.
That's right. And that's all it's doing. It just allocates the memory, so we now have that memory. Now our class has to initialize the data in that memory. And so the way that you do that, so foo alloc is going to return that memory, and then we say init, just like that, okay?
Right.
Now again, init is a method that's actually provided on NSObject. That is an object method. It's not a class method, because the foo alloc actually returned really our object. That's what it returned.
So the foo alloc has created our instance.
Correct.
And now we're calling a method on the instance called init.
Yes.
Okay.
And now you could just use the NSObject version of init, but that wouldn't really be particularly useful, because NSObject doesn't know about the data specific to our particular class, right? Our particular foo class. So in this case, init is a method that we do need to write on the foo class. And so if we jump over here and take a look at foo, I've actually added here an init method right here.
So by redeclaring it, we've overridden.
That's correct.
Okay.
Now, init is a very special method because it's used for initializing our objects. And we're going to declare it such that we have, again, just like any other method, right? We've got a return type. And in this case, it's a very special return type called the ID return type. Now, ID is used in places, essentially ID allows you to say any object, anything. You know, it's sort of a generic thing. You use it in cases like this where I'm returning an instance of myself, but you want it to be generic so that you can use it in all of these different things like NS arrays and things like that. Again, this comes from because the init method on NSObject defines it to return ID, then we need to define it to return ID as well.
Okay.
Now, the init method body itself is also very special. We have to go through certain really important steps here in order to properly initialize our object. The purpose of the init method is to set up all of our member variables and to also make sure that we actually got the memory that we expected to get from alloc and things like that. So now I'm actually going to break out here and write kind of a more generic init method just briefly so that we can see kind of how these things work. Generally speaking, your init method will look something like this, where you've got the first line of your init method, very important, is you need to call superinit. So you have to call NSObjects init so that NSObject can initialize all of its member variables as well, or whatever superclasses to your class can do their initialization.
Everything else is init will get called up the line.
Right, so it's going to go right up the line, calling superinit all the way up.
And if you don't do this, you're going to break the chain.
You're screwed. Now, the superinit there will return yourself, and you need to assign yourself to your self variable. And this is also very important. There's some debate that sometimes occurs, you know, do I really need to assign super to self? You know, is it ever going to return anything other than self? And the answer is yes. There are some very rare cases in Objective-C, specifically in core data and places like that, where it is possible that superinit will in fact actually return a different self than the self that was there when you started the initialization.
So it's the object that it's working on, it's going to replace itself.
Yes,
effectively.
exactly. And these are cases where you have things that are called class clusters, where I might ask to create an instance of this class, and in fact, I actually get something else entirely based on certain conditions of the system at that particular moment in time.
Yeah, that's loads of chapters down the line.
Totally unimportant at this point, but the important thing that you do have to remember, really important, is assign the result of superinit to self. Now, remember we talked about, you know, doing assignments in if statements and that you had to put them in extra parentheses. So we actually do that here. We say, you know, if self equals superinit, and then we have parentheses around that. Now, if something goes wrong in the initialization process up the chain, then the contract that has been specified for init says that init should return nil. Right. Nil is a special value in Objective-C that essentially means nothing. It's a non-value. It's zero. It's less than zero. It's like nada.
Not even a zero.
It's not even a zero. Technically, I suppose if you looked somewhere deep in the definitions, it probably is defined somewhere as zero. But it's better to think of it as not zero, because technically the implementation could define it to be anything. The important thing is it returns nil, okay? And nil will fail the if statement. So in other words, if this returns nil, we don't execute any of our initialization, which is going to occur in here. We'll just return self. Okay, so we don't try to do, this is where we would normally do our member variable initialization, is inside of this if statement here.
Right, okay.
Make sense?
So basically we need to remember the key thing is we have an init method. Its job is to prepare this piece of memory that the alloc has given us. We need to make sure that all the classes we inherit from, even if it's just NSObject, get their chance to do that as well.
Right.
So we're calling the superinit. We're making sure that all those other init methods worked by making sure we get a non-nil return.
Right.
If we have, we will then write any initialization code we want there.
Right.
And then we have to make sure we return ourself,
right,
which is who we are,
right,
because the init method is expected to return itself.
Exactly, exactly. So once you've actually passed this super init, right, then you can, like, for example, you know, this has this some variable here, right? Then we could actually do, for example, some variable in here equals, you know, say bar alloc init. Let's say that it was an instance of a bar class. Right?
So our class is containing other, our object is containing other objects as member variables.
Exactly.
And so we're making sure that those variables are set up here.
This is where we initialize those member variables.
Okay.
Okay. So we would do this. We'd have a whole list of member variables that we initialize here with default values.
I mean, we could do it elsewhere as well.
Yes.
But it's, you know, really...
This is the right place.
I guess it is a good rule to say that by the time your object finishes its init method, it should be in a valid state.
Yes, I would say that's a good rule of thumb. Now, there's more to this as well in that. So that's the basics of init. And if we go back over here to our main here. So if you think about it like this, right? I'm creating this foo object. I allocate the memory for it, and then I call init. When I call init, I come over here to foo, and I come into this init here. Now I've got this memory that's been allocated, right? That's self. Then I call super init, and that's going to be assigned to self. And then I initialize my member variables, only mine. I'm not concerned about my parents' member variables because that's what super init did for me. It did that initialization for me. Then I return self here, and if we come back over here again, right, that's what returns out of this right there is self, and it's stuck into object. So we get back our object from self. That's what self is.
So now we have an obj or object variable that is a pointer to a fully initialized foo object.
Correct. Now there's a couple of other little details as far as the initializers are concerned. That's what that init method is called. That's called an initializer, right? I added these other methods down here. Typically, there's a concept of what's called a designated initializer. In other words, sometimes you might have different initializers for different conditions. Like, for example, I want to pass such and such parameter sometimes. Not all the time, just sometimes. And so you might create multiple init methods that take different arguments. You can create, so for example, here's another version of init right here that takes an array as a parameter. It's defined just like any other method, and it passes it in there.
So basically we might do this because we want to pass some data in for our object to initialize itself with.
Exactly, exactly. And so typically what would happen is, you still do that super init stuff, right? And then you're initializing your member variables, and then wherever you want to store that data that came in, you would take that data and assign it to whatever member variables you have, and then call retain. Now, retain is something that we'll deal with memory management, so don't worry too much about that right now. That's just something to look forward to when we're dealing with memory management. The important thing to realize is we're getting this memory in, and by saying retain, we're taking ownership of that data.
Yep.
Okay. Now, I mentioned the concept of this designated initializer. So that then begs the question, okay, if I've got these multiple initializers, like I've got init and I've got init with array, I don't really want to have my initialization for these things in both of these initializers. That would be duplication, and we want to, we want to apply the pragmatic programmer concept of don't repeat yourself, right? The dry principle. So it would kind of stink if we had if we had to duplicate all of our initialization in each one of these initializers. So the cool part is we can actually call other initializers from each other. And the idea is that you ultimately should have one designated initializer, which essentially takes the most parameters. And the idea is that you call the designated initializer with default values for the parameters that you have not received. So for example, in this case, init with array is our designated initializer because it takes the most parameters. Let's say we wanted to also have this init method that didn't take any parameters. In that case, we could actually call self init with array and then pass a default NSArray value here that would just be an empty array if we didn't want to actually specify an array.
And just don't worry about it for now, but that call there is creating a new array.
Correct.
But we'll deal with that later.
Yes, correct.
Lots of deal with that laters. But that's the way it has to be, isn't it?
That is. So that's basically the way that initializers work. And
so if I create an initializer that takes a parameter, because init is on NSObject, so in theory I don't have to, I know we should be, but I don't have to override it normally. So we're saying I should always be creating my own init method and calling my designated, because people otherwise are going to be able to use it and my other stuff won't get set up.
yes, if you have a designated initializer, you do need to override init
As well.
to call the designated initializer. Now, that would be the right thing to do, I would say.
Okay.
So going back over here, so we've created, so basically that's how you create an object there. Now, so now we've got this object and we can do things like, some method, that kind of stuff. We've seen all these things where we're calling methods and things like that already, right?
Again, I know I keep interrupting here, but it's a pointer, but we're not talking to it like it's a pointer anymore.
No, we're not.
So that stuff we were saying about objects, we only declare them as a pointer, then forget about it.
There you go.
We're showing it's true.
It's right there. Yes, exactly. This is the joy of pointers in Objective-C, is that you don't have to think of them as pointers. They're just objects, right?
Unless, only in the case of objects, if you start using real C pointers, you have to still treat them as pointers,
yes,
otherwise you're going to get a big mess.
Yes, exactly.
But for objects, it's a pointer, but then you forget about it.
Right. Now, again, we talked about how we had to initialize this, or this data has been allocated on the stack, right? And ultimately, it has a lifetime. Now, the lifetime can exist outside of the current stack. So we can have this object that we've created here, and we can keep it around for as long as we want until we're done with it. And when we're done with this object, now we'll deal with memory management and things like that shortly, but generally speaking, you do something like object release when you're done with it. So we've done the alloc init, and then when we're done using that object, we need to release it and release that memory back. The only reason I'm pointing that out right now, like I said, we'll deal with that a little bit more when we deal with memory management, because you don't always do release. If you're using a garbage collected environment, you wouldn't do a release. But when you call release, there's another special method on foo that will get called, and that is the dealloc method.
Right, okay.
This kind of goes hand in hand with the initializer. That's why it's a good time to discuss it now, in that for all of the memory that you initialize in the initializer methods, right? So all this stuff down here where we're doing the some variable, some other variable, and some array, we're initializing these member variables. We have to release those somewhere. And the correct place to do that is in the dealloc method, which is right here. And what you want to do on each one of those is release that data and then set those variables to nil. It's always a good practice to set any object variable to nil after you've released it, so that messages to nil in Objective-C don't do anything. So by setting your objects to nil, if somebody accidentally accesses your object after it's been set to nil, it won't hurt anything. It just doesn't do anything at all.
So we're saying init is setting all this memory up.
Right.
Now, okay, so dealloc is going to get called when the object is finished with. And we'll deal with that in memory management.
Right.
Okay, another forward one. Put that in the book for later. Now, the reason we're even caring about this, if I'm going back to remembering from our talk on variables right back near the beginning, is our object variable, which is just a pointer, therefore just a memory address, has whatever scope it's sat in. So at the end of that scope, it goes away.
Correct.
But the memory up here has to be looked after manually.
Correct.
So that's gone away, but it doesn't mean our object has, and it's all sat up there and doing. So we're basically dealing with the stuff now that the dealloc is cleaning all this up for us.
That's right. That's exactly right.
And that will work out later on when that is getting called, but that's what we're doing. We're now cleaning up this memory here.
That's correct. So, the important thing to take away at this point is that you have init and you have dealloc, and these are sort of partners, right? You're going to initialize your member variables in init, and you're going to release them. You're going to deinitialize your object, basically, in dealloc. That's kind of the purpose of that. And very important, so the dealloc method always looks like this. It's always got this void dealloc, right? And then you release each one of your member variables. And then really important, if you don't want to leak memory, at the end of your dealloc method, you always call super dealloc, so that all of the parent classes, just like you called super init, you need to call super dealloc. And it's also really important that I've seen this happen to several new programmers to Objective-C. Really important that super dealloc happens at the end of your dealloc method. Otherwise, all of your parent objects crash and go away, and then you try to dealloc yourself and you crash and burn.
Because you've disappeared.
Exactly.
I guess it makes sense, doesn't it? So you always call super init first,
right?
So that everything gets set up before you do anything, right. And you always call super dealloc last,
yep,
so that things don't go away on you from your supers until you finish doing what you need to do.
Yes.
It's quite logical, quite simple.
Yes.
Just got to remember to do it.
Yes.
Okay, so we create objects,
yep,
and initialize them. We sort of know that we need to dealloc them, but we don't quite understand what we're doing in all that at the moment, but that's coming later on. What will be next?
Next, we're going to talk about those special class methods that we've seen used. You kind of alluded to it here when we were talking about this guy here. What is this here? We're actually calling a method on NSArray, on the NSArray class. So the next thing that we're going to talk about is NSArray, class methods, which is what that is. How you create them, how you use them.
Excellent. So see you back in a moment.
Bye.